Now we can hear you. Thanks, Mark.
Okay, so now you can see the
Yeah,
presentation.
yeah, everything is working. You can go back to slide mode.
All right. Hello,
Go ahead.
folks. I'm not used to the Bevy interface. I can't see the people who have joined the presentation. Um, uh,
We have almost 50 people here right now.
so I would like to make this as interactive as possible, Raphael. I'm okay
Okay.
with you turning on everybody's mics. And so if people want to interrupt and ask questions, please allow them to do so. Is that possible?
Sure. Sure.
Yeah. So just turn on people's mics and people, please interrupt. We tried to get a profiles presentation here, and the people who are kind of driving profiles have been pretty busy. And I'm leaving next week, so this is kind of my a little bit of a swan song for me. So I've been here sort of since the beginning of the discussions of profiles. So I offered to kind of give a little bit of a history of how we got here, and that's what this is. There is no right or wrong in this presentation. So if you want to debate, why or what we should do, go to the profile SIG, go to the profiles TG. That's not what this presentation is about. This is just to give you some context about what we did and why we did it and how it happened. Look, everybody knows that other architectures have groups of instructions that work together. In Intel land, there's generations of Xeons and stuff, and they get put out. And in ARM, they have versions V6, V7, V8, so on and so forth. We knew we had to do something like this in RISC-V, and this is the journey that got us to the ratification that occurred in March of 23. So the first discussions happened in August of 2020. So I got hired in June of 2020 and finally got to have some of Krista's time in August. And the first discussion resulted in this profiles policy, which is still sitting there and has not been updated. And it's got some of the original stuff. So you can actually go out to the approved policy directories. Can you guys see this?
Yes.
Raphael?
Yeah, we can see. Yeah.
Yeah, so you can see August 23rd of 2021, was where this version thing is, but it got written August 9th of 2020. So this is really about the first kind of version, and you'll see there's a lot of old stuff in here, but the rationale, is really, meant to try to get, some group of instructions that work together. And, there's a whole bunch of rules here and so on and so forth. And you can, sort of, see that. And I'm going to, go back to the profiles presentation. And here we go. And then, the first summit that we talked about this was really December of 2021. So there's a whole year of sort of discussing this and trying to get it into shape. And then I'm going to talk about what happened in 2022, 2023, and current events, because a lot happened along the way. So in 2021, we connived Greg into presenting. So Chris and I both got Greg to go ahead and do this. And these are Greg's slides from the summit. So RVI for integers. So this is basically the bases. So I hope everybody knows what a base is. A base is a set of extensions. Extensions are just, in general, an extension is a set of opcodes, behaviors, and state. And these are the base ones, so it's, add, subtract, load, store, stuff for, RV32 and RV64I. Those bases are required to build anything on top of it, okay? And those bases constitute the two, basic profiles, RVI, 20 and RVI 22. And then we had envisioned doing an RVM. But as many of you know, RVM didn't happen. And, from a market perspective, and I've talked about this a lot over the last couple of weeks, but I've talked about it over the last couple of years. From a market perspective, we've done just too good of a job for the RVM people, right? They have what they want. They don't need more. They don't want to spend time in our meetings. They just go do what they do. So, for example, there's a company called Bluetrum in China who last August, so almost a year ago, last August, announced that they had shipped over 3 billion RISC-V cores. Calista and I talked to their CTO, and he said, look, we love what you do, but you've given us everything we need, okay? We don't need any more, and we're not going to spend our time in your meetings. We take what we want and we leave the rest, right? And thank you all for RISC-V, right? Keep doing what you're doing. And the only time that people from the M world really get involved in RISC-V is that if they need something in the ISA. And sometimes they need something in the ISA, for memory protection. There's a whole bunch of people from the IBM Z world who are involved in security to make sure the security stuff, because they're using it as a boot processor, meets their requirements. That's it's an M kind of world. I have a buddy who's really more of an applications level software architect, and he does home automation in his spare time, and he uses Espressif chips. We've talked to the CTO of Espressif. They feel the same way. You've given us what we need. We put out SoCs. So Espressif and TE-Link are two SoCs that have adopted RISC-V as their main processor for their SoCs for home automation. If you have a lot of home automation at home and you look and see who the manufacturers are, chances are at least 10% of them are either Espressif or TE-Link SoCs. And so this guy has been programming RISC-V stuff now for a couple of years, and he loves it. In fact, he's crazy. He's going to make his own PCB with these Espressif SoCs. But he gets everything he needs from the community. He says it's a vibrant community. I don't have to go ahead and be part of RISC-V. You've provided GCC, LLVM. There's a bunch of libraries out there. So there hasn't been a champion who's really wanted to drive RVM. In fact, last year, Krista put out a proposal for what an RVM profile would look like, and nobody's been interested in driving it. We only do things that the community wants to drive. Now, it doesn't mean that this won't happen some point in the future, but right now there's not a lot of interest. And in fact, Philip started an RVM CSI for common system interface kind of stuff, libraries and things, and that has died on the vine, again, for very similar reasons. The microcontroller world has really, they're doing their own thing. And now we come to the primary one that has survived and is the one that is really driving the profile discussion. And in the end ends up dragging a lot of the software that is used by the microcontroller world and other things, and that's RVA. And this is a rich OS. This is general purpose computing platforms, okay? And it's a capable one because, when we first started talking about RVA, we had some people going, well, our Alexa-like device runs a rich OS, Linux kind of thing? Are you talking about that? And then somebody else said, well, our watch runs general purpose computing. So, this is more like it walks like a duck, quacks like a duck. It is a duck, So there's probably some dividing line, and you're going to see we had this discussion over time, and it ended up in another profile, and you'll see that in a little bit. But this is basically, I like to say, kind of, smarter edge device and higher, laptop and higher. But, a lot of what's driving this is enterprise applications, data center applications. But, if you look at the definition that's sitting in the profile, it's not as definitive as some people would like. But it is, what we wanted it to be. And it is being driven in a way that's consistent with general purpose computing. This is a nice little slide. We divided things, and again, RVM's still on here because M was still there. But we divided things by the family and the year. The family is I, M, and A. And then the privilege mode. So we had U, S, and M. So user mode, supervisor mode, and then machine mode, and then what the base ISA is, right? So RV32, RV64, and we started out and did some RV32 stuff, but as we've moved forward, we've really concentrated on RV64. So this is a nice little table that Greg included in his presentation. And you're going to see how this evolved over time. So this is a little slide that I put together. It's a mechanism for identifying a group of extensions that work together. Again, as I said, an extension is instructions, behavior, and state. An extension is kind of a macro itself. It expands to a bunch of opcodes and, again, state and behavior. The PSABI knows about things. The compiler tools, the M-arch string, they all know about things. And profiles are kind of like a macro, right? They expand into a bunch of extensions. And in the end, the M-arch strings that are being adopted by LLVM and GCC to support profiles basically expand the profile name into a bunch of extensions. Once that happens from the sort of the front end of the compilers, the rest of the compilers and the operating system doesn't know about that. They just use the extensions that are supported by the profiles. And then it's up to the operating system to use whatever policies that it may want in order to decide whether the system supports the extensions or if it wants to enforce some kind of consistency with profiles. But that's up to the system software to decide to do that. And it's up to the compiler to make sure that the ELF header, in the case of the sort of the Linux tool chain, to make sure that the data is available in the binary so that the operating system can make whatever decisions it wants to make. And the idea is we want to reduce fragmentation. Without profiles, everybody would have been left to their own devices, right? And that's what was going on. There were 1,000 different extensions that people were using, very complex, M-arch strings with, this extension, that extension, and it was different for every vendor and every implementation. And we knew that that was not going to work to build a software economy. And you'll see that we started moving towards that rhetoric here very shortly. And then finally, I think the thing that's really important, and I think Krista really emphasizes this very heavily, is we needed a target for implementers, right? Even though implementers can do custom instructions and stuff like that, we needed a target and say, go towards this, because this is what we're going to tell the distros and the tool chains to go ahead and do. And I actually bought this little logo. It's kind of interesting, and used it in early slides. So we actually own this, the right to use this logo, and I don't know, I liked it, so I used it. So a little strange history. So this is, the discussions that occurred in 2020 and 2021 ended up in these kind of slides that ended up there. The other thing that's important to understand is at that time, we ended up with a bunch of categories for extensions. So that there was a mandatory category that it had to be implemented in hardware if they implemented a profile and advertised they implemented a profile. There was supported optional, which meant that they could have it or not have it, but if it's implemented in hardware, it had to be supported in software. Unsupported optional, which meant that software didn't have to. Incompatible meant things conflicted. A great example of that is you can't have, the floating point in the industry registers and floating point registers simultaneously, right? Those are incompatible, and then not applicable to this profile at this privilege level. So we had this pretty complex thing, and you're going to see this complexity went away almost right before profiles got approved, and that conversation actually took a half a year to occur, and I think we ended up in a good place. Again, we're trying to work with the software developers. These conversations were going on. So this again these are conversations that started in 2021 and got pursued into 2022. But you can see that this was the stake in the ground in 2021, and it is not where we ended up. So there was an evolution there, and this is tough stuff. I mean, even though it's look, it's not complex. It is tough to come to conclusions and have something that's going to work for everybody. At the same time, I started in on this profile spreadsheet, and I think it's important tool, and I started it, and I had a lot of help from people like Greg, Ken Doxer, and David Weaver. And David Weaver had the most longevity in helping me, and is now taking it over as I leave. And he's the chair of this profile SIG, and it may morph into something completely different, and that's okay. But my idea was to try to get everything onto one page, because Krista started writing the profiles specification, and it was prose, and it had a lot of self-referential stuff where you had to look, you read something and it referred to something earlier in there, or referred to something elsewhere in another spec, and I know for mere mortals it was pretty confusing, and so I ended up creating this. And so you'll see that this has sort of some of the latter stuff. You're going to see some of the morphing that occurred, but now there's really just mandatory and optional and non-profile options. But it has it for every year, and then there's some stuff that's auto-calculated in here and things like that. It's worthwhile looking at, but it's a really great cheat sheet, and it tells you when something was ratified. It tells you, what the extensions or subsets that are included, because, we have a lot of cases like A, which, is now having a couple of subsets that got officially, they're going to be officially approved here shortly, ratified. Same things with B, and all the way down. I mean, this is, there's 120 rows or something like this. There's really 120 extensions. This is a really important tool, and either this or something like this, I think, should be use some point in the future. And then I started adding in these things off to the right. And so for every extension, the base 7 software pieces are marked as to, whether they're supported, not supported. And the key people who help fill this in are Alan Baum, who ran the ACT stuff to start, Bill McSpadden, who runs the sales stuff to start, and Isaac Chute, who's the software director for the software ecosystem. And so they help fill this in. And you can see some of the stuff is not completed, but I feel for these base 7, it's important to know for every single extension what is supported and what isn't supported. And I hope that we continue to fill these in, because I think it's important for people to have to find a place to go do this. But there's a link here, and you can go ahead and click it, and you can go down. It's they're all here. And I will also tell you the other thing that's really important about this is by doing this, we found inconsistencies in the pros. And you can go look in GitHub, and there's probably 20 to 30 issues that were raised by filling this in. So I think it's an important tool. That brings us to the end of 21, and now off to 2022. So major changes. RVM got delayed. This was the comments I made before. There was no interest from the community. M support for the mode. So, of course, we overuse letters. So RVM is the microcontroller. M is M mode, the machine mode. We don't, basically worry about profiles for machine mode, because machine mode kind of, again, does its own thing. And then in the spring of 2020, TSC created a profiles TG, and actually, for the first time, assigned a chair and vice chair. They didn't go through an election cycle. They assigned Greg and Krista because it was the first time, and they said, okay, you profiles TG, get us all the way through 20, 22, and 23. And so they're just finishing up their job of 23, and then things are going to move over to the profile SIG, who's going to go ahead and spawn things for like 24 or 25 or whatever is going to happen there. And then the other thing that happened is we split releases into major and minor releases. And a major release was where we told the distros and tool chains to go do the majors, and the minors were really more of a snapshot, because in certain years we were doing a heck of a lot of extensions. So in 21 we did 16 extensions. In 22 we did less, we only did 8. But in 23 we did like 18. And this year I wouldn't be surprised if we do about 25 or 30. And so we needed to checkpoint those things, even if they weren't major releases. And there's still some debate about what becomes a major release and what doesn't, because again, we're trying to not give the distros and the tool chains whiplash, but we're trying to put a checkpoint in place where we can say, look, these whole things work together, and here's a bunch of pros that says how this profile works together. So there was this differentiation. Where this ends up in the end, I can't tell you, right? I know there's further discussions about this, but this happened in 22, and it was decided that RVA 20 was going to be a major, RVA 22 was going to be a minor, and the initial thought was RVA 23 was going to be a major, but then it kind of became a minor because a whole bunch of Android stuff was needed. But then RVA 23 became delayed, and now there's discussions about making it a major again. And I will leave that up to the people who are still RISC-V to adjudicate and figure out. And again, folks, if there are any questions, please don't be afraid to stop me along the way. So now we get to 2023. What happens? The rhetoric changes to creating a viable software economy and therefore software portability. I'm going to show you some slides regarding that here in a second. And then the categories got reduced. So in August of 22, a couple of people were pretty upset about all the different mandatory, supported optional, unsupported optional, so on and so forth. And a dialogue began. And this really gives you a very, very big indication about how we're a community and how we get to change things. And, you know, people are pretty set on the categories, but yet, you know, there was legitimate concern about this because it was hard to differentiate between them. And so those discussions occurred, and it took like from August to January till things changed. And then all we had in the end was mandatory, optional, or options. And Krista came out with a list of why you have options. You know, one reason you have options is there's some things like security where you may have things that are very regional. You know, you have NIST in the US and Shanghai in China. You're not going to necessarily make that a mandatory global kind of thing. There are some things that are optional because they're, you know, just something that's not commonplace for RVA, and so on and so forth. And RVA and 20 and 22 got ratified by the board in March of 2023. That was a very big move. I'm telling you, folks, this was very hard. Think we started this August of 2020, and it took all the way to March of 2023 to get this ratified. And some people weren't happy with what was in there. It was very difficult. We worked very hard to make this happen. And, you know, once you put it in the ground, then you can go ahead and move forward and go from there. It was also decided at one of the board meetings that marketing was going to pick names for major releases. So, you know, the initial thought was they were going to use some kind of gem names for releases, like A for Amber, you know, whatever. And that discussion is still going on. The reason is because, you know, the RVA 20 and 22 names, they can become long in the tooth because, you know, those years move by, and we chose not to do V1, V2, V3. Everybody had a little heartburn from what went on with other architectures, and there wasn't a really good consensus on what to do. And so we stuck with the years, and it's not clear that there's a good resolution to this, but marketing is having these discussions with you know, folks who are running the profile SIG as we speak. So these are some slides that I started showing in that time frame, and really started talking about portability. So we basically said you can't have an economy around software unless you can take an application and move it from one implementation to another. And we said, look, if you have a profile and an ABI and an API, then you could take something from one implementation and move it to another. That means that software vendors can compile one set of bits and release it on multiple platforms. And that's what we need, right? And so that discussion became the center of the whole profile discussion, right? And we tried to have this drive everything. And I think it was pretty successful discussion, and people understood it. The press understood it. Analysts understood it. And along with that, also came the platform discussion. And for those of you who know, the platform task group in fact, just got approved. It has a bunch of components to it. the platform runtime services, the boot runtime services, the SoC hardware services, the security platform services, and profiles are all part of the platform. That's to enable system software to be compiled once and run on multiple implementations. The application piece is so applications can run in multiple implementations. So this portability became a big deal because software economy is really important. And during this same period, we also had the advent of RISC, and so software has gotten a lot more visibility within the RISC-V ecosystem. And again, this is sort of the general rhetoric that we were showing people about things. And I think it's important to understand that a profile that is approved today will take years to show up in implementations, and probably has a lifetime of 10 or 20 years, right? And then I don't think the coloring is working really well, but I came up with this representation. Of what the roadmap looked like for profiles, and those releases are the marketing names that we talked about. But you can see what's in the profiles, and these are things that are showing up in these profiles, and what will show up in profiles in the future. The thing you can't see here is the rendering didn't work well on bases. Those are the RVI family of things. Those are the base instructions: load, store, jump, branches, add, subtract, and logical. But this shows you in general how this works moving forward in the future. This gives you an idea about how this looks. This is not a complete list. This just gives you the sort of the high points of these things. And then you can also see that there are more extensive names to things, because it's U mode and S mode, and there's 32-bit and 64-bit and stuff like that. But I hope that something like this, either this or something like this, will end up being used to explain the roadmap for profiles for the future. And interestingly, this roadmap is a lot of the same things that are really being worked on today, and you're going to see a lot of these extensions and profiles and other things show up in the next year or two. The one thing, oh yeah, so and then now this is my last slide. And then we can just have a discussion, and people can ask questions or whatever. You can ask questions about anything. So one thing that happened this past year is quite an interesting thing, is the affirmation of the C extension as part of the RVA profile family. It got approved with RVA in March of 23, but there was some concern about it. On the pro side of C, there's very clearly a significant memory impact to even to 32-bit instructions, and there's a lot of work done early on how to do things that fall on 16-bit boundaries. On the other hand, there are a lot of architectures out there that were that had problems since the 80s. We went to this fixed width instruction, and people went away from 68Ks and x86s where they had variable length instructions, and so there were issues about cache lines, cache line boundaries being overrun. So if you had 16-bit instructions, you can have a 32-bit instruction that goes over a cache line boundary or over a page boundary, and that didn't fit in with a bunch of people's ideas about architectures. And so there was a fairly heated discussion, and then finally it actually got decided by the board last November, and they decided C was going to stay with RVA. There's still some heated battles in the community about what's going to be supported in the tool chains and in the distros. But C is part of RVA now and forever. We also created an RVB, and that has a couple of things that are optional instead of mandatory. The biggest one of which is vector. And the reason is because vector requires a lot of logic space. And there, again, if you go back and some of these people who have, watches or Alexa-like devices who want something with a smaller footprint, want all the stuff from RVA, but they don't want some of the things that are really consumptive. And so RVB is now an official profile. It will come out with RVA, but it has a small delta of things in order to make it more conducive to less capable or less, smaller devices. We declared RVA 23 as a minor release. It may go back to be a major release. Again, stay tuned here. I don't know what's going to happen. Also, TSE created a profile SIG to figure out the future of profiles and suggest future profile families and versions as TGs. And they have really basically just started out. That's David Weaver as the chair and James Ball as the vice chair. David Weaver is from Akiana and James Ball is from Qualcomm. And then, then we added the base 7 components as I showed you before in the profile spreadsheet. So those are the things that have occurred recently. There has been more participation in the profiles discussion than broadly than probably very many other discussions I've seen inside of RISC-V. So we've gotten people like the distros to show up. So there've been people from Red Hat and Canonical and SUSE and so on and so forth. And so it's generated a lot of interest and a lot of discussion. There's been a lot of work in the toolchain groups in order to support this, the PSABI. And so, I'd say that, we've done a yeoman's job to get this done, an incredible amount of work by a lot of people. And hopefully, this is just the beginning. That's all I have to show. So, Raphael, where do you want to take this from here?
So we can open to questions. So we have David and James here. I'm not sure if they are willing to talk a little bit about what's coming for the profiles and what they plan to do as part of their SIG.
Yeah, sure. I'm here. I think Dave's here too, though.
Yeah.
Did you want to say something, Dave?
Well, Mark, that's really psychedelic when you I had that screen is going on to infinity. Sorry, that was pretty distracting.
That's what Bevy does. I don't know. So
okay, thought for a second it was on a bad trip. Anyway, so we've just gotten started out with the profile SIG. There's already been a fair amount of discussion. As Mark said, James and I have been in discussions with the RVI marketing folks about the external naming of the profiles, and seems like there's some new ideas about that now that may resolve some of the issues around naming, but we'll see how that goes going forward, because that's really also in the early stages. So we're certainly looking forward as we go along here to nailing down what is needed for future profiles, both with a lot of input from the distros, which is great to have, and organizations like Google Android, which is another major consumer of profiles that we see. It's to be determined whether, in an M mode, or excuse me, not M mode. See, even I got confused just now. Whether a microcontroller profile is needed, an RVM type profile, but that's still very much open. And this background that Mark has given is really helpful, and I'm sure I've only been involved with RISC-V for about 3 years. Mark's been around longer than that. I'm sure a number of people on the call have also, but there are also a lot of people listening in who've only been, involved for a year or so, and all of this background is really valuable to have. I'm going to shut up and let James make a few comments if you'd like.
Yeah, just to explain something maybe organizationally. So there's 2 profiles groups right now. There's the profiles SIG, the special interest group, which Dave and I are the leadership for. And so that's profile SIG. Its charter is to do things like gap analysis, do outreach to the different stakeholders, like the operating systems that Dave was mentioning, tool chains, the IP vendors, the whole community of people around profiles, and then to also work to see if if we can justify the creation of other profiles. There's also been talk of a profile called RVS for soft CPUs, for FPGAs essentially. And so that's one of the roles we're doing. There's also the profiles task group, which is pretty much wrapping up right now. And the profiles task group is really the RVA and RVB 23 profiles task group. And so that's being led by Krista and Greg. And so task groups at RISC-V International, if you're not familiar, they get created to create a particular specification. And then when that specification is done, then that task group wraps up. So the SIG that Dave and I are leading will be working to basically work with RVA leadership to be able to justify the creation of future task groups to create updates to the profiles. So we're looking for all the stakeholders to reach out to them. So if you want to reach out to Dave or myself, please do. And we want to make sure that your needs are understood. Dave and I are kind of doing we're trying to write down some of the documentation that maybe was in a particular profile release, but maybe actually has concepts that span more than one profile release. And so that's probably something that belongs more in a documentation that's not part of a particular profile. So we're working on those kinds of things and trying to work on things like, well, what's the criteria for, how do you know when it's time to release a new profile? And is there a concept of major and minor? What does that mean exactly? Write it down. There's a lot of different opinions about that, but we see it as our role to get that written down and make sure we get alignment within RVI on that.
So we have 2 questions here. I believe those are for Mark, but Dave and James, feel free to chime in. First question is, someone is willing to confirm the purpose of RVB. Actually, it is to remove vector from a small core.
Well, it's not just vector. There's a couple of other things, but the intent is really to help people who have less real estate.
Yeah, it's RVA minus. So vectors and hypervisor are optional in RVB, but mandatory in RVA.
Yes.
So it's for more like embedded markets where they don't, like your Alexa device or something like that doesn't do a lot of heavy computing of vectors, or things like Wi-Fi routers that are running Linux. They don't really need a vector unit, and it is a chunk of area and cost and whatnot. So hypervisor is not as big a chunk of real estate as the vector unit, but
yeah, probably also affects power consumption.
Yeah.
Another question here is, if RVA 22 took 3 years to agree on, do you think RVA 23 will be ratified before 2025?
Yeah, look. I mean, the first one took a long time because it was the first one, right? And 20 and 22 happened coincidentally, right? 20 was retrospective, so you can look at them as the same thing. I think it took us a long time because it was the first one and we had to learn a lot of things. So, for example, just getting categories reduced and stuff like that. So now we have a little bit of a paradigm. RVA 23, the profiles TG, and all the people on the phone here, Alan and James and David. I mean, everybody's agreed to the content. We're in the final throes of trying to get the contents of it, because not all the contents have been approved yet. So we're trying to get all the contents ratified and then get it through the process. So I think it will happen in 2024. I had the little discussion with Greg and Krista about renaming it to be 24, and they started like pulling their hair out. So, I mean, that's the problem with the names and the numbers and stuff. And I'm going to let better people than me solve that. But I have full confidence that it will get ratified in 2024.
Yeah, we're working with marketing to come up with a list of requirements for naming and get alignment on that. And so one of the requirements is that we going forward, you don't want to have the year in the name, because we do want to have, we want to figure out what the release criteria is. And then based on the release criteria, then that should basically make it clear, well, what's the release cadence? How do you know when it's time to do a release, And so those are things that we're still kind of working out, right? And you can see that we're in a learning process on that.
We have one more question. One more question here. Mark, that's for you. Can you comment how interruptive handling fits into profile, like plicky and clicky?
I'm sorry, can you repeat that?
Okay. Can you comment how interruptive handling fits into a profile like plicky and clicky?
How interrupts?
Yeah.
Well, I mean, look, there are obviously there are extensions that are being approved, and some of them fit into M mode and some of them fit into S mode, and the ones that fit into S mode are either part of a profile or not, right? And that's I think the job of the profiles TG to go ahead and decide how they fit in. Again, just remember what the ultimate goal is. The ultimate goal is to be able to, from a system software perspective, to be able to ultimately to be able to ship, one set of bits, configurable, of course, but one set of bits from a system software vendor and have it run on multiple implementations. I mean, the reasons why we've done, AIA and click and all these things is to provide, a common set of ways to do these things. So I think it's up to them to decide, what is going to be appropriate.
Another question here is what are the ramifications of RVA 23 being a minor release? There seems to be a lot of products based on RVA 23.
Yeah, look, just to let you know, I mean, the reason we came up with the minor and major is, we got feedback from the distros going like, we're going to get whiplash if you make us do things every 10 seconds, right? But we needed these checkpoints along the way. And so we tried to identify the stuff that was needed in order to handle the group of things, in order to support the adoption by various distros. And it looked like RVA, 20 was good enough for a group of people until the bunch of stuff that was coming in, we had hoped in RVA 23 to support a larger group of people, including Android and other folks. And then it looked like that stuff wouldn't happen. And then RVA 23 got delayed. And now it looks like it might happen. So the implication, I think, is just the messaging to the distros and to the tool chains about what they ought to adopt and what they ought to support, obviously, the tool chains in the MArch line. But I think a good part of it is this messaging thing and the stuff that James and David are working with Tiffany and company on, as far as like making a marketing name. The goal is to make it clear to the community about a few things they ought to adopt, and not make it every year. When I don't know if you guys know Heinrich. Yeah, and I talked to him at the RISC-V Summit last year in Europe, and we talked about the frequency, and we all agreed that the first couple of times it may be a little more frequent than they want, but we know that as you start going into the second half of the decade, it's going to have to be a lot less frequent, right? And so maybe ignore the numbers and the dates, for the first couple times, but think down the end. I mean, this concept of major and minor is partially, trying to set a precedent for when we get to a little bit more of stasis. And I think we're going to have to be a little bit more flexible in the beginning, based on what we know at the time, when things get ratified.
I believe we have one last question here. That's an interesting question to close the session. And the question is, how can you increase the popularity of RISC-V microcontrollers and increase the number of projects using them?
When you say microcontrollers, you mean like embedded, or what are they?
There is not specified, Mark.
Well, I mean, look, we are doing a lot of things. I mean, there's no one simple answer to this. I will tell you that one of the things from an RVA perspective that we have all talked about, we've talked about it at the board, we've talked about it at TSC, we've talked about it at chairs, is, look, we had a couple of years during COVID when the supply chain was really an issue. And we've come out of that, and we've started seeing decent development boards starting to show up, right? But, they need to progress even further, right? I'm waiting for something with Vector 1.0, hypervisor, PCIe, at least 128 gig of memory, right? And I want a development board that can do that and do most of RVA, at least 22, maybe 23, because that's how you get people to develop, right? I mean, look, we have strata of software, right? You got the boot software, we're doing pretty good there. You have the operating systems, there's a lot of great work going on there. Talk to Isaac Truth, he talks to all the distros, and while there's still work to be done, I'm grateful for all the progress in the tool chains, very similar. But next we need to start talking about what I would call infrastructure software. So, we've done some work in managed runtimes, but we need to also do work in things like databases and runtime libraries, and advance them further than they are today. And then eventually applications, right? So the way you get those done is you give them tools to get them done, right? And that means hardware and operating systems and so on and so forth. So I think, it's fundamentals. I mean, look, anybody who's been in the business for a long time knows you've got to go ahead and feed all these pieces in order to make an ecosystem work and make sure that people, get stuff done. That being said, there are still things that are gaps in RISC-V that, the teams are working on. We have about 25 active task groups that are working on specifications. If things go really well this year, there's going to be something on the order of 20 to 30 specs that are ratified. Some of them have been being worked on for over 2 years. Notable among them is all the security stuff, right? All the trusted execution stuff, all the control flow integrity, the security model, which is the overall story. I mean, that's amazing. The platform specifications, right, which includes profiles, that's amazing. All the matrix stuff, which is just starting. I don't think it's going to close this year, but it's going to make progress this year. That's amazing. And then a plethora. I mean, there's probably going to be, over a dozen fast tracks with plugging small holes of gaps that have, available in other architectures and need to be available in RISC-V. No shortage of great ideas. And we built a scalable organization, and people are really stepping up to the plate. I'm very grateful for that. I walk out of RISC-V after 4 years and just blown away by this community and what it does and what it's going to do. I know that there's, we don't require reporting, but I think there's probably in excess of 30 billion RISC-V cores out there for profit. And it's just growing all the time. Again, a lot of IoT and embedded devices, but growing up to, edge and wearables and servers and HPC and so on and so forth. So keep going at it. And if you see something that you think needs to be done, we're a community. We're only as good as you folks are. So speak up, help us know about what we need to do to make things better.
And one last question arrived, Mark. I think we have time for that. So
sure.
The question is, should RVI discourage claims for support for non-ratified profiles? Look at the problems with Vector 07.
No. You missed the point. I mean, one of the wonders of RISC-V is we allow that kind of innovation. And yeah, there was some confusion early on about how to deal with custom extensions and so on and so forth. But competition breeds innovation, and a bunch of things that have started out as people's custom extensions are ending up in RISC-V. Things like the conditional ops and stuff like that. No, I think the reason, I had this discussion with Dave Patterson when I joined. It's like, the two big reasons why people use RISC-V were cost and flexibility. And I, arm wrestled with Dave. It's like, Dave, it's flexibility. And he said, no, it's cost. And then now everybody's saying it's flexibility. In the end, the reason why people want to use RISC-V is flexibility. They can do what they want. They can do what they need, right? That's what it is in the end. That's what, in the end, people felt around Linux. Not everybody goes ahead and does unique, different things with Linux, but they can. They feel ownership. It's their house. RISC-V is your house. It belongs to the community. People can do what they need when they need to do it. And people are doing a lot of innovation. It's really great, whether it's in the implementation of existing instructions or adding, custom instructions, or, if we can't get to something quick enough, they could do something to get to market. I mean, that happened with Vector. It's happening now with Matrix. We will have, Matrix, from RISC-V. Does it, cause some angst in various places? Yeah, but I think the community is figuring out. Go talk to Christoph Molnar about how they're supporting custom extensions in the tool chains. I think it's a very unique thing in history, and I think it's brilliant, and I don't think we want to stifle it in any way, shape, or form.
I do want to say, Simon, that I see your question. There's different markets that the RISC-V targets, right? And so the situation, so in some cases, there are markets where they really need to have a lot of binary compatibility. You can think of like Linux distros or Android applications. Need to have a lot of binary compatibility between different devices that are all part of the same market, right? And in those markets, they have less of a tolerance for things that the markets themselves, not RVI, but the markets themselves may make restrictions on what can be put in the processor, especially things like pre-ratified extensions like vector 0.7, right? They may, but that's not RVI's job. I mean, as Mark says, we're about supporting flexibility. The market can restrict those things. And we can do whatever they need. Like there's this new extension called SSS strict or something that helps to kind of meet the needs better of those markets. And but there's other markets where, yeah, no, like you can. They don't need that binary compatibility. It's like source compatibility, and you compile all the Linux and all the apps down for your market for your device. And so, if you want to have a bunch of custom extensions or pre-ratified versions of things, then that market's fine. So I think we're trying to help people kind of think that way or understand that there's not one size fits all here, right? And so, and how does RVI make sure that we can meet the needs of the different markets and different stakeholders?
And profiles are a counterbalance, right?
Yeah, profiles are there to help, with to help the needs of the markets, especially right now. We're seeing the strong need for the application markets. The other ones we're not sure about, for example, microcontrollers.
Simon, you can talk now.
Hi. Yeah, sorry. Can you hear me?
Yeah.
Yeah. No, thanks for the responses. Very interesting. Bit of background as well, and filling in some of the history behind all this stuff. I think my point was only it's a terminology semantics question. If you call something RVA 23 or you call it vector support, I think RVI, correct me if I'm wrong, would like, the whole point is ratification and standardization, and that the ISA should do what it's been specified to do. I think it's the weakening of a specification process that is the concern I'm raising.
Yeah,
I think the market, right?
Yeah, but also I think there's less of an issue than you think. We worked very heavily with one of the major providers of V7 to ensure that they call it a custom extension, right? And so Alibaba in particular, and they were very reasonable about it, and we've worked hard with them to make sure that it's marketed appropriately, and I think it's a good thing. So I think it's going to take people a while to get used to it because we're kind of a new beast. But once they get used to the fact that they see an X in front of something, they know what it means. I think it will be okay.
Got it. Thanks.
I believe we do not have any more questions. Anyone would like to ask the last question?
I do want to say thank you to Mark for this presentation, and of course for all of your work over the last 4 years that enabled the development of profiles in the first place.
It was an honor. Thank you.
Thank you, Mark. Thank you, everyone that joined in today's session. That was a really special one. And see you all in the next technical session. Thank you. Thank you for joining.